Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Friday evening. It's Free Energy Friday. It's January 13th, 2025. Welcome to the show. We got Jarvis on, we got Lulu on, and we got Mr. Phillip on. Welcome to the show, everybody. Yeah, last week I didn't do a live show. Most people probably know my father had some serious health issues and he's been in the hospital for the last 2 weeks. I'm happy to say he is making a recovery. The doctors have been amazing. They've really helped his condition. He's starting to get some movement back on his right side again and starting to get his strength up. He's talking better. So he's probably going to be there a couple more weeks. The doctor says he doesn't want him to leave until he's walking again. So he seems very confident and very happy that his progress is actually starting pretty fast. His recovery is going really good so far. So, yeah, on that note, we're going to continue on here. We had some great discussions last week offline, and I think we're going to just do the same format like we usually do. We're going to start off with Mr. Phillip. He'll kind of get us up to speed on what he's been at and where he's going with his projects and his physics, and we'll just kind of wing it from there. Hey, Phillip.
Hey, just one sec here. All right, there you go. Can you see my screen? Yep, there you go.
Yep. Yeah, you can see it.
All right, the little intro here. I just want to repeat what I said on Bernie's shows last week because it's very important, and I wanted the my channel to have the recording as well. And so last week I was talking about my my deduction of superluminal dark photons. I kind of deducted it independently because, and it turns out after some research, I saw that there are people that inferred the same possible dark photons that would explain the GRB 22109A anomaly. So it's kind of the dots are connecting here. And why did I deduce the superluminal dark photons independently is because I was thinking about the double slit experiment. Find some images here so to remind people what is. Yeah, there you go. So that's the double slit experiment here. You have constructive interference and destructive interference. The destructive interference are the black stripes. And so I always wondered what happened to the energy of a photon if it goes black, if the frequency turns out null. So it's the same thing as the annihilation process I was talking about previously. The energy is actually, so I deduce that the energy must be converted into kinetic energy. So the photon needs to travel faster if it loses electromagnetic energy. So it needs to be converted into something else. So this way the dark photons with null frequency would go FTL, even close to infinite speed. So I deducted that independently because of the double slit experiment. And yeah, again, the it's kind of inferred by other people as well that the superluminal dark photon would explain a lot of things. So um, it's pretty much guaranteed that they exist and that I'm right about my little deduction. Um, and so yeah, so it's definitely possible to communicate faster than light, faster than the speed of light. But how do you convert a dark photon into a normal photon? That's another challenge. That's gonna have to be figured out by some new experiment, but I'm not sure how yet. But I'll figure that out down the line. And yeah, so that's what I want to share. That I already talked about that last week on Bernie's show, but this week, what I'm working on is more. I want to work on the piston. I figured I want to start studying piston and how to harness pistons because if we create a void of energy, like I was talking the other day, to create a void of energy will create a force. Just like if you have a void of air, a vacuum. If you have vacuum, then you're gonna have some pressure on the vacuum container, which is a force, and so you can create pistons with the void it creates. So I want to do the same, but with the ambient energy density that we are in. I wanna be able to harness the ambient energy density, and yeah, that's the idea I had this week, but I didn't have much time to work on that more than anything else because I'm working on my software at the same time, the C++ superset that I need to deploy next week. So I need to finish it up for good. And yeah, that's my part here, and I don't have much more to add. But
Yeah, that's good. Talking about photons. So what I did just before we went on tonight, I showed Jarvis that if you take a regular LED light like this one here, and you put light up to it, you get a voltage. It works similar like a solar cell. So I was getting 0.062 volts. Now, if you get
yeah,
yellow LED lights, apparently they work the best. I was able to get over a volt out of one of these. So yeah, you put an array of like say 500 of these, it'll work same as the solar panel. It picks up the photon.
nice. But
Yeah.
did you get the idea about the dark photons that
Right,
the energy is converted into kinetic energy if you lower the frequency?
right.
How did you figure out it's dark photons, or is that part of like the double split experiment derivatives? Is that like how you come up with dark photons?
Um, yeah, I didn't come up with the term dark photons, but after some Google research, I saw that photons with low frequency, that's how they call them, dark photons. And my friend told me he didn't like the term dark photons because it's not a special photon, just a photon with no frequency. So we shouldn't use a special term for that. He's right. It's just a photon with no frequency, um, but yeah, that's one to another Nobel Prize one of us should have Like one of us wins every month. Every month we win. We find Nobel Prize worthy stuff, but we get shadow ban on the contrary.
Yeah. Yeah, another one we were talking about is my end machine. I just want to show the experiment. So the theory is Bruce De Palma back in the late 70s discovered just by rotating solid magnets at high speed. And when you put your negative on, say, the axis point and one on the outer perimeter of the magnet, you get current, but very, very little voltage. So I kind of recreated his experiment. Now, his back in the 70s and 80s, his rotors, he had two of them side by side. They're about almost 1,000 pounds worth of magnets. And so he was able to get 2,500 amps at 60 volts DC. So that thing was cranking pretty good. So I recreated his experiment. I'll just show it here.
What is Jarvis doing? Some macaroni with the flamethrower?
It looks like he's got scallops going there. Yeah.
Yeah, with the flamethrower.
Yeah. Yeah. Screen share. Show my end machine experiment. Can everybody see that okay?
Yep.
All right. So I'll just play it loud. So I won't really be able to talk while it's running. But you'll get the idea. I'll put the meter close so you can actually see the performance. See, we're already at 10 amps, and I'm not even pushing it yet. It's only maybe about 800, 900 RPM. There's no power going into this. It's generating that amperage just by spinning magnets. I'm going to go up.
Hey, is that Gerald on the chat? Cool.
So that was creating 20 amps at about 60 to 100 millivolts. So it's very little voltage, but very, very high current. So it's definitely worth the study. Bruce De Palma also discovered when he put analog clock on the shaft, it was dilating time. Time was slowing down or speeding up.
So up to what current can you get?
This one here, the highest I think I got with this one was just shy of 30 amps.
Okay, but can you crank it up to 200 amps?
Yeah, I probably could, but I have to spin it a lot faster. When I cranked it up, it was about 2,000 RPM. Now you'll get a greater amount of current. Like those are just shy of 3 inches diameter. If I went to say 4 or 6 inch diameter, the current goes up way higher. So the bigger the diameter, the more current you get.
Yeah.
So say I had a 12-inch diameter magnet. Yeah, I'm looking in the hundreds of amps. So
nice.
Yeah, it was a very cool experiment. It was great to see that what he was talking about, just spinning magnets create current, and it most definitely does. So
nice.
Very successful.
I might use one of those. One of those.
Well, the thing is, because it's direct current, you're very limited on the amount of voltage. If you have 1,000-pound rotor, with 1,000 pounds worth of magnets, you'll be able to get about 60 volts DC at 2,500 amperes, right?
Yeah, that's exactly what I need. Low voltage with high current.
Yeah, so this would be the device you would probably want to make.
Cool. Yeah. I'll talk to you, man, for sure.
Just spin magnets. It's as easy as that. It is that easy.
How you call that?
You just spin magnets.
Okay,
You
spin
spin
magnets.
Yep. So you have one connection on the here. Let me show you. So go back to the picture. I'll just kind of back it up. Okay. So you can see the magnet here where my cursor is through the picture. That's where
Yeah.
one connection is. It's on the outer diameter of the magnet. And then the second magnet will complete the circuit. But in most cases, a lot of people just use a single magnet. So if that's the case, you're going to make your connection on the axle. That'll be your negative. And then you loop it to the other side, go through your amp meter. And I know it's creating amps because the amount of potential voltage it's creating, it's only 60 to 100 millivolts. It's very, very tiny voltage. So what we're looking at here is pure current, 100% current. If
That's
I had a lot
awesome.
more, so if I had a lot more voltage around it, I probably would have fried this meter, because when you get into that kind of potential, I'd have to have a real big ass freaking shunt on this. Because if I didn't, then it would have smoked this meter. It would destroy it.
Okay.
So yeah, it's just by spinning magnets. So I got two fishing magnets. They're 2 3/4 inch diameter. I got two of them, and they're within about one. The south poles are in the middle, and the north poles are facing out. So I had to squeeze these magnets together really, really hard to get them close. So after I compressed the magnets together as close as I could get them, it was these magnets were, I think they were 600-pound lifting capacity, something crazy like that. They were very high. So I'm dealing with a very, very strong magnetic field. So if I got the the two south poles in the middle, man, was it hard to push them together. But I got them probably within about an inch of each other. So I'm creating a huge amount of flux field, a very, very strong flux field.
Nice.
When you
And,
when you
and to make them spin, you can use this AC
yeah,
current.
yeah, just a DC motor. I got a DC motor right here on the side, and it's spinning it.
Okay.
And I got that hooked up to just your standard motor control, and just crank up the speed on it. The faster it goes, the more current you're going to create. So I
Cool.
was at about, like, this one was slightly out of balance because at that time when I had it, I haven't used the device in a while. And oh yeah, the other very important thing is with this end machine, you have to use ceramic bearings. You cannot use steel or aluminum. Nothing. It has to be ceramic because
Okay.
you cannot have steel. What will happen is the magnetic field will actually create a huge drag on the bearings.
Yeah.
So you have to use ceramic.
Or you could use zirconium
Anything that's
or
ferromagnetic, anything that's not ferromagnetic, you're okay.
yeah. Okay.
Yeah.
Or tungsten.
Tungsten, as long as it's not ferromagnetic, you're okay.
Yeah.
So that won't create the drag. So the ceramic magnets for this device, I 3D printed out the whole case, the motor holder, the coupler in the middle. Everything was all 3D printed, very, very precise. Like I think it was over a month designing the case for this because I had to have it so precise. And it paid off big time. I was getting fantastic results with this. So, yeah,
Nice.
very, very cool machine.
Very cool.
Jarvis is that looks tasty.
Yeah, man. We got a chef here. We got a live chef in science. We got a science class and chef. I'm getting hungry. I'm getting hungry just watching them.
Yeah, I'm gonna get something to eat after in 15 minutes or something.
Yeah. Yeah, we got Gerald online. Gerald, I sent Mr. Gerald a link. So, Gerald, if you got some free time, jump on.
Yeah, and Gerald, I want to Putin. Yeah. I want to say that if you got a better idea to harness ambient energy, I'm down to hear your suggestions. Because
Oh, Philip, your friend is in. Simple
uh,
Man 911's here.
oh, cool. Yeah.
Yeah.
I'm going to start showing mathematics because I know the 911 likes it. um, so,
I feel like
yeah.
I feel like we got a cooking channel going on here.
Yeah. And
Is tungsten expensive?
Yeah,
yeah,
it's pretty
tungsten is
pricey.
extremely expensive.
Sorry, guys. It's loud while I'm making this. So I don't want to cut you guys out. It's like a bunch of click, clang, and click.
I just want to try it.
It's some shrimp and rice, and the other half goes to my dog. My dog eats chicken and rice. She eats really good, and some peas. She loves her peas.
Yeah.
It's funny, like farmer dogs like $60 a month, and I'm just like, I'm just gonna cook some chicken for my dog and save a lot of money.
Yeah.
I just can't afford farmer dog. But hey, it's cool. I'm gonna shut the mic off. I know it can be loud.
Yep. Right on. Everybody likes good food. So yeah. So anyways, Bruce De Palma after that was working with a couple of guys, Adam Tremblay and Tiwari from India. And Tiwari in India, he was part of the Nuclear Generation Authority in India. And he replicated Bruce De Palma's machine and was getting the same results. So as time went on, Bruce De Palma, I guess, had some issues with some people that were not too thrilled on what he was doing. And to make a long story short, he basically left the U.S. and went to New Zealand, where he lived the rest of his days and also passed away there. And I think it was 1997 he passed away, if I'm not mistaken. Adam Tremblay, they seized his device, put a gag order on him, cease and desist all manufacturing of his device. So this device obviously got the attention of the power brokers and in the government, and they were suppressed big time, especially Adam Tremblay as well. And yeah, kind of a sad story. They were really good engineers. Well, Bruce De Palma, he graduated from MIT professor. He was top-notch, physicist and electrical engineer. And
Oh, yeah, they suppressed him?
oh yeah, big time. Oh yeah.
Oh, yeah.
He
What
had
year
to leave
was
the
that?
country. He left the country, I believe, around 1994, 1995, and he moved to New Zealand, pretty much in exile, and he passed away a couple of years after that.
Wow.
1997, 1998 time frame. That's when he passed away.
That's weird because I'm that's weird because none everybody wants to suppress new technology. The military they can make use of it, you know.
Well, the thing is, the M machine is not a new machine. It was designed by Michael Faraday back in the early 1800s. So it's nothing new. It's not a new machine.
Okay.
But Bruce De Palma kind of resurrected the device and made it into a device that could actually be used at a power plant.
Yeah.
Also makes a really good welder too because it's high current.
But yeah, Bruce Palma actually knew how to do it. He's one of the true guys that understood the physics too. When it comes to the Lorentz force, he escaped that as well.
Yeah.
A lot of
there is.
Yeah.
Yeah, you see, when you pull a load off an end machine, there's no cogging, there's no lens effect, there's
Exactly.
none of that restrictive kick down from taking a load off it.
Sometimes there is assist instead of cogging. It actually assists
Yeah.
if you do it
Yeah.
right.
But the wheel just keeps trucking along. It doesn't notice the currents being taken off it.
Yep.
That's the great part about that machine, and I
Yeah.
think that's what scared. I think that's what scared the powers to be.
Yeah, for sure. I mean, it's one of the first public, like, obvious ways to get more mechanical work out than the electrical power that you're putting in. The M machine is a very fascinating.
You know what? That
I think
video
it's got to
there,
be a later topic though, because it's really advanced.
Yeah, like this video here is one of the best, most viewed video on my channel. It has over, I think it's over 7,000 views on this.
Well, good. At least that means that people are not stupid. I'm hoping people aren't stupid. I guess they're not. That makes me feel better.
Yeah, it's got over like 7,000 views on this.
Yeah, there's definitely
despite the counters being shadow banned.
Yeah, that's probably part of the reason why I got shadow banned, because of this video.
Well, Bernie says he's rejoining. So, Philip, when it comes to magnetohydrodynamics having a vortex, what do you think about that?
Well, I'll show you the videos that I have.
I like those. They're very informative.
Yeah, I'll show you the. Is it just one sec? I got. Can you see my screen?
Yeah. That's a really important experiment, I think. It's simple, but the trick is to make it look simple. Like, it's really not that simple. You know what I mean? Sometimes when people present things online, we try to make it look simple, but it could take like 5-10 tries to make it look that easy. You know what I mean?
Yeah, but I have a open-hearted version of the video I want to show. Yeah, this one right here. So inside the machine, you can see that that's how it works. You can see the liquid metal flowing with the current. You have a magnetic current, and then you have the gallium flowing. So that's the a very very low voltage and high amperage, like 40 amps in this case.
That's 40 amps. Yeah, that's pretty cranking.
But in this video here, I'm using 100 amps or 120 amps, something like that. And you can see the weight is shifting. So it clearly shifts the weights. And
what was sorry to interrupt. What was the voltage?
The voltage was very low. It's nothing more than 10 volts.
Oh, okay. So you had high current, very low voltage. Yeah. Okay. Yeah.
So yeah, that's all I care. The cool thing about the current is it can be reused. So I can reuse the current in series for another engine next to it. So I can put a stack of engines that are going to use the same current in series, and I'm going to lose a minimum amount of energy, because the resistance is very low. It's extremely low. So I can put a stack of experiments in series using the exact same current, and That's the cool thing. It's gonna multiply the force, and and yeah, because according to the analysis from University of Sherbrooke, they did a theoretical analysis and they figured my engine is 160 times less powerful than a drone. It's not. I'm not very that far, 160 times. I just need to reuse and to maximize the vortex. Reuse the same current
Yeah,
for
maybe
multiple engines, and
maybe
or
the end machine is what
reuse
you need.
the heat loss and all that stuff. So you just need to maximize it, and I'm gonna have a
Let's go, Gerald.
very similar engine, but with being stealth, it's not gonna make any noise. So
Yeah, I think the end machine is maybe what you're looking for, but you would have to upscale what I've done.
yeah,
So if you
Gerald,
were to get,
I'd like to know what you're doing with the light. Do you think Gerald may be able to get involved? I know Bernie's trying to step on too, but it's good to see Gerald.
we got Bernie here. Bernie's back.
I know Gerald's working with light, which is very, very interesting. A lot of people don't realize the energy of light is based off the frequency. Like even with microwaves, they seem like they have a lot of energy, but if you have ultraviolet light, this is not medical advice. I put a little bit of hydrogen peroxide on a womb that was with MRSA, and I shine a UV light on it. And MRSA is very difficult to get rid of. MRSA is known to be resistant to antibiotics. And all I did was spray some hydrogen peroxide and hit it with the UV light. The energy of the UV light is very potent. And I was able to get rid of the MRSA. And that's not medical advice. And I'm not telling you that that's something you should try. But
yeah, leave that one alone, please.
Sorry.
Yeah.
But UV light, it's not really the intensity, it's the frequency that matters there. The UV light actually has a lot of energy to it. And of course, the intensity matters too, the amplitude of the wave, but the frequency really gives electromagnetic radiation an energy that's based off Planck's constant times the frequency. I don't know if Philip knows that.
The energy Planck's constant times frequency.
Yep.
That applies for photons and electrons because they are basically the same. Photon has mass, and you can convert this energy into mass.
Sometimes we think microwaves are more energetic than UV rays, but it's not true. You know what I mean? The frequency, whenever you get into ultraviolet, it may not seem like it's doing anything, but it's actually jiggling those electrons around more than you can see. It's actually more energetic to use UV light. That's why I got this little guy. Sometimes whenever I charge aggregates and stuff, I'll use a little UV light. Try to put some sort of, you know what I mean? UV light really people don't really understand that the energy is not in the intensity of the wave, it's in the frequency. Sometimes it's both, but you can get away with it with UV light very easily.
Yeah, but did you know the speed of light is a function of frequency?
I think the energy is a function of frequency. The speed of light is constant because whenever you increase the frequency, you shorten the wavelength. So that's the constant. Anytime you
but they saw
shorten the wavelength, and it's going to be C.
They saw a supernova exploding billions of years ago.
The speed of light is
very
constant,
far away.
The energy is variable.
and the light of different color is not hitting the earth at the same time.
Sometimes we just have to agree to disagree. I think you're right. Sometimes with like supernova blasts and stuff, like you see different frequencies of light, but it could be an energetic response that puts off those frequencies in a sequence. Instead of it being faster than one color, it could be an explosion that happens in a sequence that gives off those lights in that sequence.
Yeah, I know, but I calculated using the Selmayr
I have to agree to disagree.
equations what the delta time would be, and I calculated 12 seconds.
Well, my
Actually,
partner would agree with you, so I'm not saying you're wrong. Everybody sees everything different, man.
Yeah, I know, but I'm just saying, keep yourself open-minded. That might not be what Einstein said, you know?
It could be. Yeah, you're absolutely right. I mean, when it comes to experiment, like they have seen different color spectrum hitting at different times. So you're right there, you know, but I'm just saying it could be a reaction that causes the spectrum to spread like that.
Yeah, I know what you're saying.
Either way, you know what I mean? But the way I see it, like the reason it's constant is because the higher the frequency, the smaller the wavelength. So you increase the frequency, you get a smaller wavelength. So it's going to be C. You know what I mean? But the energy is not constant. That's what we're focused on anyways, is the energy, right? It's not the speed. The speed.
Yeah, exactly.
Who cares about the speed?
But there's the thing. There's the thing. If you take X-rays or gamma rays, and you do destructive interference with 2 photons of gamma rays, then it's going to create dark photons. But where is the energy going? It's going to convert into kinetic energy, so it's going to travel FTL.
The energy is the question, not the speed, in my opinion. You know,
kinetic is the speed is energy. Is a form of energy.
The frequency H is Planck's constant times the frequency is the energy. It's all frequency.
Kinetic energy is a form of energy as well.
I'll agree to disagree.
Yeah. I'm reading what Gerald is saying. It's pretty funny.
Hey, Lulu, how do you think we could, in theory, talk to spirits? Do you think it's possible to make a radio that can communicate with ghosts?
Yeah.
Cool. I do too.
Yeah.
Oh, you're driving. I'm gonna wait until you get home. I don't want you to talk right now. Just focus on what you're doing.
I'm listening. Listen. I'll interrupt if something sparks, but a lot of things are sparking. I have a question. Like the double split experiment. What if we change it instead of how the slits are to sideways? Would it do the same thing?
That's a good question. What do you think, Mike?
I don't know. I'm lost right now.
Well, it's kind of like when they did the ether test, right? Like normally it was on this plane, and then when the guy did it on the 90-degree plane, it proved it. You know what I mean?
Well, so I'm going to interject with my thesis on this. It was something me and Mike were talking about.
I'm just gonna go for a smoke. I'll be right back.
Sure. Yeah. And it's that the wave particle duality is misunderstood. And it's not that it's not a particle, it's that a particle is actually a field of coherent standing waves. Therefore, it's always waves and a particle when it's in a particle, because it's just a complete field, and it's a misunderstanding or misinterpretation of what a solid particle actually is.
But I believe in wavicles. I think there is a possibility to show them both ways, especially with de Broglie waves, and he called it the pilot theory. So he can actually model it as a particle and a wave. So I agree with you, Bernie. Waves definitely matter, but it's almost impossible to say it's a wave or a particle.
You're misunderstanding what I'm saying.
indistinguishable.
It's that it's
Yeah.
a field.
No, I do.
It's a
I
field
do.
of
I understand that, but I'm saying
freestanding.
when it comes to pilot theory, well, it's an additional layer.
Oh, Gerald, I was listening clearly, so you should hop back on and tell us some more.
Let's go, Gerald.
Yeah, what you got,
Gerald's
Gerald?
gonna put us in his
What
place.
you got?
Come on, Gerald, dude, what's up, man? You're welcome.
Hey,
to come
we miss
I
you,
love
G
talking to
Dubs.
Gerald. Gerald's one of my favorite guys, man. He's like so intuitive. He's one of the best engineers I know.
Oh, absolutely.
He's
Like
just
Gerald,
natural.
like
He's like a
our
natural.
Gerald, right? You're talking about our Gerald, the one that
The
disappears.
one and
comes
only
back.
WPG Enlightened for Truth too.
Yeah,
Okay.
Gerald's a
Online.
natural,
No,
man.
Gerald's awesome. Like I
Yeah.
like, man, he makes things like the way he talks. He should teach. I think he should teach. You know,
Yeah.
like definitely.
Yes, Gerald, come
on
teach
out,
us all
Gerald.
right now.
Does anybody have a way to send him a link?
He already has one in his email. He's just
But
busy
my
at
mic
that.
is is there
He's
can
scared.
you accept somebody, Bernie?
Yep, yes I can. So
Okay.
feel free to hop on, Mr. Gerald. Yeah, so yeah, see.
Jarvis, you were asking me about spirits. You know, I want to tell you, anybody could see them. You just have to really sit still,
And dark.
and look at something, focus on something, just one
Mhm.
one item, like put it in front of you, and then you start to see the shadows around you.
Yes.
Yeah.
I've
You
seen
don't have to,
spirits.
yeah, you don't have to do much. It's not, it's not hocus pocus. It's just focusing.
They actually,
you
I
know,
saw
Another
YouTube
way
video.
another way too is through sleep deprivation and fasting, right? The longer you go, the more you're able to
Well,
interact with
any deprivation, even sensory deprivation,
Exactly. So sensory deprivation is reaching that stillness, that
Yeah.
calmness,
Mhm.
that being able to go out of body or just interact with that other realm, at which point you are able to see not just spirits, but auras and very, very much more.
Yes.
Either that or you buy an electromagnetic camera to do the job for you,
Yeah.
you know?
Or I believe cobalt lenses also kind of work.
I was gonna say I just saw a YouTube video that says that this certain type of glass is kind of forbidden because you can see the aura, and cobalt's cobalt's on the edge of seeing auras and stuff. Cobalt glass is
Yeah,
really
right. And that's on the UV spectrum side, right? The one other half of complete missing visible light and energy spectrum of humans. And then the other side is, of course, the infrared, right? And that's the hot side. And that's supposedly where they also see the demons. So it's very, very scientifically evident that energies and beings of energy are with like just outside of our visible light spectrums. But if you're able to increase the amount of light you're taking in or close it, right, completely dilated or undilated pupils, all of a sudden you seem to be able to see more.
Yeah, and what intrigued me in the past is whenever they started making baby monitors, they used to use walkie-talkie technology. And walkie-talkie technology, when it first started, was different, and you would be able to hear ghosts much better when it came to walkie-talkies back in the day, like real walkie-talkies.
Crystal radios.
Well, it's similar, yeah. Crystal radios is definitely probably better. You're right. But I'm just saying, like the walkie-talkie technology when it came to old baby monitors, you could tune in. Have you heard of the skull experiment? And it's not skull like this.
Yeah, the skull. Charlie, shout out to Charlie Crawford, Charlie C. He's a part of it, and he actually replicated one of their like ghost radio interactor things, whatever the
Yes.
technology is.
Edison actually he gave blueprints to it.
It was
brother.
the ghost of Edison that channeled it to them apparently from the afterlife. Yeah.
Dude,
We got to have Charlie back on to go into that. It's something else.
is that Charlie C? Charlie C's cool.
Yeah,
man.
you got it. Charles Crawford III, Charles C.
Yeah, I love Charlie C. He's a good guy, man. He does a lot of cool stuff in collaboration with Sean. I wish Gerald would have the guts to come on here and talk with us. What's going on, Gerald?
Come on, Gerald. We miss you.
Or
Or Gerald. Come on, Gerald.
A link if you want to join.
Come on, the Oilers won yesterday. It's time to party,
I'm just
man.
making shrimp and rice, guys.
Yeah.
Just hanging out.
Canada, yeah.
Anybody want to talk about
Hockey.
whatever, man?
I found something on Facebook Market, an optometrist lenses, like all their, how when they measure for a person's vision, their equipment, those glasses, like the glass things. If I buy it and I build a small stand and put it up to the sky and look at it, wouldn't you think I would see different anomalies because these have
Out
different
of phase,
frequencies?
yeah, out of phase. Interesting.
Yeah.
I think so too.
It's not that maybe hard. It's just different magnifications.
That's cool, Joe. No worries, man. I understand. That's cool, man. That's do what you do, man.
Oh,
That's
prayers are with your son, Gerald. Prayers are with your son.
Hopefully, he gets a
Gerald and Gerald Jr.
Gerald Jr. Yeah.
But I would say, Gerald, whenever you do get a chance, it's always fun to chat, man. You're one of those people like to cling on to
rubber room is always ready.
He's the OG of oil geometry.
Yeah, Gerald's on another level. Are you still driving, Lulu?
Yes, I am. But I'm 5 minutes.
Don't rush. Take your time. So, when it comes to hydrogen, Bernie, do you think sodium hydroxide is a good catalyst?
Very much so, and that's definitely a huge thing, and even more so when you're able. Am I going to give away too much of a secret here? When you put it on as a crystalline lattice compound onto your electrodes, that's when some real magic starts to happen. Specifically, which one charged of those electrodes?
Cool.
One thing I can reference from the Energy of the Vacuum series, they were talking with William Doyle and all the British engineers. They say you'll always know when a German has a project on the go is they use a tremendous amount of hydrogen peroxide.
Energy of the Vacuum series is one of the most brilliant series if you're getting into the game.
There's some other possible magic that comes in with hydrogen isotopes and hydrogen peroxide in specific reactions as well, but I don't want to get the stream taken down for divulging too much, so we'll just leave it at that.
Yeah.
Sounds good.
As far as creating energy and working with the stuff that the Germans were working on in World War II, hydrogen peroxide was one of the key components in a lot of stuff they were working on.
Yeah, they would actually mix hydrogen peroxide with sugar, like a sucrose solution, and use it as a rocket fuel in the CIA.
I saw that. I know that. I know how to build one of those.
So really all you need is sugar and hydrogen peroxide, but
and cat litter. Cat litter.
Yeah, I mean silica. If it's okay, you got bentonite cat litter and you got silica cat litter. So both are really kind of interesting on their own rights. So it depends on what cat litter you're saying there.
I don't know. It's cat litter
Is it
don't
silicon?
use it. Like nothing that touches
Yes,
anything
it
will
clearly
ignite
is.
it. Like any
Yeah.
the slightest heat
Like
will
this
all
cat litter.
Yeah, the one thing we should stress too is playing with hydrogen peroxide.
This is
and
silicon.
sugar.
But bentonite's very interesting too.
You have to worry about the heat, guys. So be very careful when you're mixing these chemicals together.
Yeah.
If you're not sure, do not do this stuff.
Yeah, and
some of the stuff is-
outgases
Yeah,
as well. Can be
gases.
People don't
poison,
realize how
all
dangerous
sorts
it can
of
be.
Flammable, explosive reactions, all sorts of
So-
stuff.
Yeah.
Hydrogen is the
Dangerous.
magic particle that it transfers the energy in and out of essentially what some want to say the vacuum, or basically the ether or 0 point back and forth. So depending on what you're doing and the phase shifting, and if it's in an ionic interaction, you
Right.
do have the potential for like subnuclear energy amounts.
Yeah, but we're talking about modern day alchemy here.
Pretty much.
You know,
Yeah.
yeah, it is. It's modern day alchemy because
It
I
is.
don't think back 3,000 years ago they had hydrogen peroxide. So, right? So,
Never know though. That's the thing, because
debatable. They
you're a
had
master alchemist.
sulfuric acid. You know what I mean? If you have sulfuric acid, you could have hydrogen peroxide.
well, don't forget with sulfuric acid and certain metals, say like magnesium, you got some major heat happening.
Yeah.
I seen a friend of mine took
All
a
this
magnesium.
is dangerous. You know what I mean?
Oh, highly dangerous. A lot of gas coming off it, which is very noxious. A friend of mine, he was cleaning some magnesium plates. It was oxidized. So he put in a hydrochloric acid. Oh my Lord. I thought the guy was gonna he was gonna die right in front of me because he had the video.
Lord.
We're doing video chat, and he's putting it like like a glass tray, like the ones you use for baking. So he's got one tray of hydrochloric acid and the other one just with regular water. So he would pick up with the tongs, he would pick up the magnesium and drop it right into hydrochloric acid.
Dude, if you start seeing green gas, run.
Green?
Yeah.
Oh God.
When the chlorine comes out, it turns green.
Okay, put it to you this way. He was doing this outside on his driveway. And I thought he was gonna keel over. I go, dude, like, what are you doing? Like, this guy has no like filter for like danger. So, you know what I mean? So I said, dude, get it out of there, put it in the water. So he takes it out and he's like, he's coughing away. And I go, oh my
that's
Lord
so
God.
dangerous.
I'm like, dude, man.
I can tell you two chemicals that
That's so dangerous. And it's like that's one of why I like my reactions. I couldn't have stepped up exponentially more, but it's like I'm dealing with making hydrogen, so I'm using 0 to like maximum 5 volts for a reason, because I don't want to explode.
You don't need that much.
And then there's so many other gases, and then when you start getting into the
when chlorine
cavitation
starts
and
coming out, it literally
supercavitation-
looks like a green gas.
Well,
around
not
you.
even
that's what
better
I'm
run,
doing. But
dude. You better
even
run.
worse killers are these other types of radiation that come out when you're dealing with the fields of these triple solenoid coils, as well as like anything getting into actual production of supercavitation reactions.
Yeah, if you're going to get into the high plasma energy and stuff like that, where you could be releasing gamma or beta particles, I highly suggest you get a what do you call
Faraday cage?
a meter for radiation detectors.
Absolutely.
Which I have.
A Geiger counter.
Geiger counter.
Geiger counter. Thank you.
Very good.
Sorry, I couldn't get it out. But the other thing too was when he put the plate in there in the hydrochloric acid, the amount of heat that this thing generated. Holy cow! Wow.
Just gonna scoop
People,
out for.
if they
for
don't know
10
what they're
minutes.
doing and they do something very simple, it's honestly very dangerous. Like that's why it's so tricky to disclose this stuff. You know what I mean?
Yeah, exactly. You got to
I
be
don't want
very
people to hurt themselves inadvertently.
Yeah, when
But
you're
you
getting
could.
into the alchemy stuff, I'm telling you, you better damn do your homework on it.
Yeah. You better have an apprentice.
Yeah, or chemistry background or whatever.
Yeah, and an actual lab and a very, very ventilated spot.
Outdoors
and
is
like,
probably the safest. Yeah.
I actually have a gas mask, but I prefer going outside anyways. But I do
miles
have
and miles away from any houses, businesses, any structures.
Yeah, right. Like, so this summer I gotta like rent a generator, I guess, and go out to do some microwave experiments with the transmutations that will happen with the different
dude.
stuff.
There's some cool stuff with the glass cobalt bottles on that too. I'm sure you.
Oh yeah, but you need more
I have-
industrial microwaves to get the glass to get the gold.
Well, I've got
them out where the powders that you just.
It's like flour gold.
Less, yeah.
Yeah, flour gold within the bottle itself, but like people were taking Home Depot sand and getting flour gold.
And
like really, any source of sand,
silica, right? Quartz and gold are always in the same beans.
Absolutely, any big source of sand you can get flour gold out of it. Everybody wants nuggets, but you can literally like
actually. Exactly. There's exponentially more. That's the whole mystery of or technology of rare earths, right? Is rare earth elements is because it's just there's so much more, but it's in the powder form, and you have to either chemically react it or you can electrically break it down, electric fields charged and pick it out. And
another good source.
Another
good source of gold.
Mike, I'm sorry.
Another good source of gold is take beer bottles and smash them up.
Yeah, that's what we're just starting with. That's what.
There's good resources on that route. What I was getting at though, normally when you pan for gold, you wet it and you shake it. Like that's the traditional way to do it. But I would dry the sand and shake it, because then if you dry it and shake it and you have an electrode on the bottom and attract it like the philosopher's magnet, then you flip it upside down and you got the gold on top. All you got to do is have an electrode on the bottom and shake it dry, not wet. You know what I mean? Shake it really dry, shake that sand dry, and you'll get the flour gold to deposit onto the electric bottom, and then you flip it up and down and take the bottom off. You get gold right there.
Now
it's a dry pan instead of.
Here's one for you, Jarvis. There was a guy years ago,
but I just disclosed it, so whatever.
Jarvis, there was a guy years ago who made a magnet that could lift gold.
Yeah, an electric lifts gold.
It's an electric, exactly. It's a type of electric. We're giving away all the secrets right now. We're giving away the secrets.
It's that easy, folks.
So the guy used a giant induction coil.
I saw it. Yeah, but you can literally make an electric and do the same thing. The thing is, because gold wants to acquire a negative charge. So if you had a positively charged bottom plate,
should we be discussing this right now, or should we be making more with your patents? But anyways,
this is something. It's an application for it. You know what I mean?
Absolutely.
I'm not. There's many applications that I'm not trying to patent or make money on. I'm just trying to inform people that I just want them to think creatively. There's many different ways you can use them if you're creative. You just got to be creative. That's it.
Yeah, exactly. Red mercury works. Red mercury is just mercury and iron oxide.
That was in the TR3B.
Yeah.
High speed, different types of red mercury, but that is a basic one when you get it spun.
Iron oxide. Red iron oxide and mercury together will make red mercury.
I think Schauberger kind of advanced that.
Yeah, well, the Nazis were working on that.
Yeah,
in
the
World War
more
II.
different elemental oxides as well as monoatomic elements that you add into the alloy, or what actually it's ionic. That's the crazy part. That's the magic of mercury. It's in the ionic liquid elemental state. And that is where you get the plasma, aka ionization.
Well, what is an electret? It's like an
Um,
ionized solid. Instead of it like being an ionized gas, an electret is literally like an ionized solid sitting there.
Yeah.
It's
In
another
a lower
phase of
valence
matter,
state, though. It's in a lower valence state. It's just got one of the charges of
but
it.
it can be positive or negative. Is the thing? It
Yes,
can be
sir.
a lower valence
Absolutely.
or a higher valence. You know what I mean?
I fully
So
get it. I fully
it's
get it.
another.
It's a
You
key
know, they
part
say
of
plasma is
technology
another
I'm
form of
developing.
matter, but you can literally have a solid that's a plasma. You know what I mean? Because it's ionized. It's permanently
Yeah.
ionized.
Well, it's yeah, and it's just in that ionic valence shell active state as a solid is what it is, and that's where you get the superconducting and that energy interactions. And that, ladies and gentlemen, is the magic of monoatomic metal elements in a nanosolid state.
Here we
Called
go. Disclose it a
atomic
little
phase.
bit before we go backstage on the real magic science. You know what I mean?
Still got an hour left, but at the 1 hour mark, ladies and
Hey,
gentlemen,
if
right
our chat
there,
is
you
big
listen
at this
to what
time,
we're
they deserve
saying.
to know, man.
Last
They know it
week's,
anyways.
well, last week's after show.
You know,
and,
boy,
what's that, Lulu? Oh, she
go
disappeared.
ahead.
Last week's backstage we did, Bernie, was actually pretty cool. That was a good backstage.
It was good.
Oh, yeah, that was a long
last
work.
one I wasn't there. The last one
Yeah, the last one on Bernie's show there.
I
with
wasn't there.
Jeremiah.
You were there. It was exactly
You're-
1 week ago. But yes.
Yeah, you're with us.
Or yeah.
Me, you,
Or
Bernie,
no, just a couple
was
days
good.
ago.
Mike,
No, that was Wednesday. That was on
Jeremiah.
Wednesday. That was Wednesday.
Yeah,
Maybe-
Wednesday. Yeah.
That should be Patreon type content there. You know what I mean? If we had like our backstage chats, that's literally like where money is worth it, because we really have.
I know, Gerald. I know, OG. That's why we got to get you up here.
That's
But-
the
or out here to Calgary. That's
backstage supercharge.
It's always fun though backstage. I agree.
Backstage supercharge, yeah. Oh, yeah.
I think we should do a Patreon on the backstage.
Yeah, you probably could. Yep.
Yeah. Not a bad idea.
Yeah.
Because there's only things we can say for YouTube. I'm sorry,
we won't
Liz.
be normal. We won't be normal if others are watching, and then the conversation kind of has limitations, versus
This is very true.
the things that we could
very,
just-
very true. Because there's
Yeah.
difference between private
No.
development time and what can be made public at the moment.
I'm just like making shrimp, but trust me, in the background we got some shit going on, dude.
We have the Faraday Research live cook. We have our Pasquale here on screen.
But it's cool that we're all working together. That's what I like. Everybody got their own avenue. You know what I mean? I like it. It's a good group.
Yeah, it's a good bed for.
It's Friday. Love you, Gerald. Prayers with your son.
Gerbo.
Yep.
Next time, man.
There. Yeah, he hasn't been on in a while. I
guess I'm gonna eat some shrimp and rice. It made me hungry. I'm smelling it.
Go to it, man. I always eat when I do a show. I'm so bad. Whenever I do a show, I have to eat. I don't know why.
Yeah, this I'm a faster intermittent, and I eat later. This is the first thing I would eat today.
Well, I fast pretty much 5 days a week, 6 days a week. I fast, so I'll have my last meal at like 6, and then I don't eat till the next day. Really.
So intermittent. Yeah. I do intermittent fasting. I don't know. This is the first thing I would eat today if I ate it, but I'm gonna share it with my family. You know, I gotta cook my dog's chicken.
Yeah. Don't
She's
forget the
good.
dog.
She's good, man.
Yeah. So, so what are your plans with the electrodes that you have been working on? That idea that I showed you earlier tonight. You going to try that or?
Definitely, yeah.
It's not that hard to pull off. It's pretty easy design.
Yeah, and there's, like I said, like, you know, there's so many different ways.
Well, the electret, let's break down the electret for a second. It's a static field. It's not in motion, right?
Right. But Tesla said if it's static, we're in vain. If it's in motion.
Right.
But what was he was literally talking about this. It's not static. It's not still.
No, what you can do,
you can do many things with this
thing. You can manipulate it with magnetic field or even a frequency.
Right.
So if you were to
especially with metamaterials like alien scientists.
Well, you could do like say like what I've been using with transducers. You can actually use a transducer to manipulate the field that the electret is producing. And if you can make that oscillate in between an inductor or coils, you got some electrical power, right?
Like Trump's uncle, whenever he went into Tesla and rated his documents, he came up with something similar. But instead of using an external charge source, you would just use electrodes, and it's the same thing.
See,
and Eric Dollard admitted that was the only device that he has ever witnessed to give over unity. And you know, it's not BS, folks. I mean, but
there's so many real inventions too that don't have to be over unity. They're just over engineered because our system of our current grid and technology is designed to be so inefficient that there is a lot of working technology where you get like 200, 300, 400% gains, but it's
most
just
of our technology is based
the gap
of magnetism. Most of our technology want to use magnetism for motors and stuff like that. You know what I mean? And we're not used to using electrics.
It's incorporating all of those technologies together is what it is,
today, right now, everybody uses magnets. You know what I mean? Today. Now, whenever electrodes are as proliferated as magnets, the world's
going to engineer electrics and magnetics back and forth within your flywheel, and boom!
Magnets are just the tip of the iceberg. Magnets are intriguing, and but it's just the tip of the iceberg. You know what I mean?
Yeah, that's if you're generating a magnetic field using an inductor.
But that's what we've been doing, since
that's what regular science has always used, because it's always
creating of gravity. More magnets, more gravity. I said more magnets, more gravity.
I think more electrics,
more energy.
It's energy density.
If you have more magnets,
density.
Magnets are the easiest to picture because that's all we're used to. But imagine 100 years from now where you could buy an electric just like you can buy a magnet. You can't do that right now. You can't literally just go and buy an electric like you would a neodymium magnet or something. Imagine if they're so powerful like neodymium magnets 100 years from now. The technology you can do with that is exponentially greater because all the elements on the table are electric. You know what I mean? 4 of them are magnetic: nickel, cobalt, iron. You know what I mean? Like when it comes to paramagnet or ferromagnetic substances, only 4 in the periodic table, but all of them are electric.
See, what I like about electrodes is the fact that they are self-sustaining. Okay. And you can draw power off them, and they'll
recharge
power. They recharge themselves. So you're not putting any energy into this.
No.
This is a field that's being held by
It's a
an electric.
completely
Oh yeah.
it's a completely different world. And like we're just in the beginning of, like I said, we're that guy with the magnet on the river and saying, this is telling me that way is north. Yeah, this magnet is telling me we're just the person with a compass right now, not understanding where it can go. But it can go, just give it 100 years and it can go big.
Oh, give it 5 years, my friend. Give it a couple of years. Like we're gonna make some things happen.
Dude, it won't take long.
The electric garden. We're gonna start the electric garden.
Yeah, once it starts, it's not going to take very long. But I'm just saying, like, people don't get it. They're like, who cares about a magnet? I'm just like, okay, you're welcome to think what you want, but look what magnets have done for
Hey,
us.
are you challenging Ken Wheeler to a fight now?
I'll challenge anybody. I don't care.
Magnets are always a losing battle. They always will be.
Mhm.
Electrics,
They're 90.
an electric, it will always be better than.
That's what I'm saying.
Always.
Anything a magnet can do, an electric can do better.
Yes. Yeah.
But it takes.
And it's using both fields together. But yes, for electrical terms, an electric absolutely better than a magnet. But for the rotation and drive, it's putting the electric and magnet together.
Right now. That's what I'm saying. Like, nobody knew a hunk of iron could do the work that a neodymium magnet does now. It took the scientific ambition to understand how magnets work to get to the neodymium magnet. It's got so much strength, and all it takes is a little bit of an investigation into electrics to get to that point. And it won't take very long.
Yeah.
It's in its infancy, is all I'm saying. And there's so many things. There's more things you can do with electrics than you can magnets. You can have monopoles. You can have a electric and a magnet. You can orient the fields different ways, and we're going into a new avenue that's never been explored. And it won't take long. Like I said, 100 years is like a far out thing, but imagine 100 years where magnets and electrics work together with our technology, with metamaterials and understanding material science, and getting to the level of like literally hovercrafts and like anti-gravity. All that stuff is coming through that. It will. It's a crack in the dam that's going to just let it all out.
Yeah, definitely. It's going to take a while, right?
It'll take a while. Yeah.
It's not going to happen overnight, but there's some people doing some good work out there.
Yes, absolutely. Yeah, I'm not expecting it to be quick at all. And and there's actually things I want to go into after this. This is kind of like the beginning, and I think Mike, you get that too. It's just kind of like something that should be more understood. It should be understood that there are permanent electric fields, just like there's permanent magnetic fields. Most people don't know that. 99% of the people have no clue what an electric is. Well, so the challenge is to introduce the concept, first of all. You know what I mean?
See, Tesla referenced electrostatics and electrics back in the day. And he says if you really want to make huge advancements, electrostatics is where the real magic happens.
Yeah, and his patent to make transformers and capacitors, he used carnauba wax and beeswax. The structure that the first electric was made out of, the insulation he used, but he used a vacuum. He vacuumed it out, and say he made a transformer. He would vacuum and introduce the wax so that there's no air, no humidity, and then he would pressurize it with air afterwards to compress it even further. He knew about this, but it's literally a transformer, and I call it a diatribe. any high capacity electret is a diatribe. Okay, that's what I call it. And diatribes have been known for a long time. But that's what that is having a high capacity electret. Then you get a diatribe, and the diatribe can power stuff.
Right.
You know what I mean? But it's really the capacitance in that case.
Yeah. So to hold a static charge, you have to look at the materials in the list that are best for holding electrostatic charges. There's quite a few things to choose from.
There
And
is.
then you can implement
It's a new
that
field.
break
But
it
if
down.
you've been watching what Sean's been doing, you can see he's doing work with it.
Yeah.
You know what I mean? We're just getting into it, but he's still showing that you can do work with them. That's the first It's the first time I've publicly seen somebody do work with an electret. And I don't mean to be plasma channel. He did it too, but there's ways to cheat that me and Sean are thinking, okay, he could have just rubbed it on a shirt for a triboelectric charge. Is it really permanently charged like we're doing, or is he cheating? And we suspect that ours are real because we're doing real science. You know what I mean? And I'm not calling him a snake salesman, but maybe he's doing it for views, and we're doing it for real science. We're trying to show you the real science of this. You know what I mean?
Yeah, for sure. So always be skeptical on what you see online, if it's real or not. And
we won't hold it back. If it fails, like Sean says, 90% of the time it fails.
Yeah. Well, failures eventually are going to get you to successes, right? I've had a lot of failures.
But we can't fail and pretend like it's a success, because then we're just snake cells.
Yeah, true. Very true. Exactly. Yeah.
We want to help people. We don't want to lead them down a path. We're trying to teach people.
There's been a few projects that I worked on, and I just couldn't get them to work. Right?
Yeah, but it's cool. Like you said, every time if you fail, it's still fun to fail, in my opinion.
Well, it's learning, right? And it's figuring out what works, what doesn't work.
You're like, but once you start thinking about it,
right? Figuring it out, because so many different inventors, they intentionally left things out or misdirected like crucial small parts. So your first build, it's like, oh, it doesn't work. Oh, debunked. But then it's like, oh, wait, the real geniuses, the real inventors, the people it's meant for, figure it out and see, oh, no, this is the hidden middle secret sauce.
And that's why it's cool to show failure. Yeah, to show like you thought this would happen when this happens. Nah, you're wrong. Just like I was wrong. You're wrong too, though. I don't get it, but I was wrong, and I'll show you why I was wrong. I don't know. Maybe you'll understand it better. But the failures are just as important as the success. Because
most definitely.
Yeah.
Most definitely. It's the only way you're going to learn, right? It's by failures.
Yes.
I started from ground nothing, no electrical experience whatsoever, and going step by step, learning a little bit more here. A lot of reading, my own personal teaching, watching a lot of conventional science and trying to change it, go in a different direction, see if it works or not, or seeing a good video, like the end machine was a good example of that. Spinning magnets creates current. It can't be this easy. And it was. And it works very well.
And that's the opposite side, you know what I mean?
So you kind of have to do your own debunking, what you think is real and what's not real. And if something looks too good to be true, try it out, see if it works. If it doesn't work, then you.
But it's sad that all these bullshit things get all the views. You know what I mean? That's what really pisses me off.
Well, that's by design. That right there is called.
It just pisses me off so much, man. I can't stand it. like the people that are really like trying to help people are shadow banned, and like all these people that are just like, and we can obviously debunk it, and people are going to invest money and not get anywhere. They're literally scamming people, and they get all the views, and then the people that are really doing it.
The most bullshit free energy devices have got millions of views. And then I got stuff that actually works.
Yeah.
And I got 4,000 subscribers. Like, and I'm lucky to get 7,000 views on it.
It's the real deal, you know what I mean?
What the hell, you know?
Like people are starting to group up and be like, "Oh my goodness, this is where it's at," and like it's still, you know, you would think that there'd be more interest in real science, and it has to be suppressed.
It's the algorithm that they're putting out.
I just don't understand.
They put
like you should have 100,000 viewers easy. You know what I mean?
Well,
not even close.
Mike, whenever
I haven't gained a subscriber in 3 years. Like they've kept me at 9,500. Like it's
see what I'm saying though, dude. It just doesn't make sense. It doesn't make any sense at all. You know what I mean? I don't know.
Yeah.
Mike, whenever you like start to have like a barcode, and you produce it as a product with like a SKU number and barcode integrated to, that's when your technology is gonna people are gonna notice it. Why? Because it's a product we'll start to buy, understand what the alternative is and how it works. You have to be, like make a few and create a hype. It'll work. It's
Yeah, it definitely takes a lot of time. Like these power cells I'm working on like crazy. And I'm going to try another design very soon that I think is going to help out in a few areas. Like this, I've been going at this cell now probably over 2 years, 2.5 years now. And I'm still trying to make improvements on it. It's doing everything I want it to do. So I'm on the right track. It's just trying to get the longevity there, right?
Yeah. What is it, like 10 years, 15 years, 20 years? Like you there's different ones that you've made throughout, and each of them had some,
I would I would say 10 years is pretty respectable.
I mean, that's
Joe?
Hey, what's up, everybody?
What's
up?
Hey.
Welcome, Joe.
Joe Fuchsia.
Yo.
Welcome.
Yeah, what were you guys talking about a second ago? You were talking about YouTube suppression? Gotta love that, huh?
Yeah.
We accidentally cut off Lulu. I'm sorry.
Oh, I'm sorry, Lulu. Hello, by the way.
No, I'm good. I
Well, yeah, we were looking at this a couple days ago, Bernie, right?
Sir, and I wanted to bring it back up because it was like you said it, but I've been thinking it a long time. It's like you use the hydrogen as your way up through buoyancy with a giant balloon, and then you use it as the fuel once you're up there, passed out of the gravitational field, and consume it, and that's how they're supposedly powering this disc-shaped craft in this United States patent from the year 2000.
I had an idea like that. Like I was thinking if I was cremated, it'd be cool.
Spacecraft. Oh,
sorry. I was thinking that like I called it astronauts. Like if I were cremated and go into space, it'd be a system similar to this, to where you would have like hydrogen balloons lifting you off a platform and then explode it at one point to launch it into space. Like whenever you just let
why you don't need to explode, because you just use the buoyancy aspect of getting out of the atmosphere.
Yeah,
and
but
once you're up there, then you can ignite it as a
at one point where it started to You know what I mean? At one point
Yep.
where it gets to that point, you can just detonate it and launch it straight out into space.
Oh, here we have
No,
in
but-
1973.
I tried that one time in the backseat of my friend's car, and he told me it smelled real bad not to do that again, and he was afraid I was going to light his car on fire.
It's a cool idea. So morbid.
Oh, here's a T Brown. T
Every
Brown.
time you just do one window, like, you know, like it's funny if they roll down their window and you don't, it's gonna come towards them. It's gonna be like stank, like as it goes out the window. So you don't roll down your window and let them roll down the window, and it's gonna be like, I'm just
Oh boy, oh boy.
But I was also talking about too backstage a couple of days ago, is all you have to do is create a magnetic containment chamber on the outside of the craft and have the hydrogen in front of it, and it will lift you off the ground. So you don't physically actually have to have a balloon there. If you have a magnetic containment unit that would hold the hydrogen in that space.
Well, okay, so the thing about like magnetic containment is that you could actually simulate that by jacking up the amount of energy into the magnetic field, because the more energy you put into the magnetic field, the size doesn't change. It actually contracts and compresses.
Right.
The more energy you have into it, because it changes the flow rate of the toroidal structure of the magnetic field. So it actually begins to collapse.
Mm.
So, that in itself could work as magnetic containment. It doesn't have to be a material.
Yeah. Yep.
true.
Mm-hmm. That's actually straight from Ken.
Oh, is it?
Yeah.
Oh, this is the Otis Kerr stuff.
OST.
Yeah, so Otis T. Carr is very interesting in that. Well, let's see.
Oh,
Come
remember
in.
I was talking about the energy from the vacuum series? You had the three British engineers.
By the way,
And-
I would recommend anybody to watch that.
Yeah, the one engineer, Bert England, that was working on that.
So-
apparently, I didn't know this. Bert England actually spoke with Tesla personally.
Mm.
He actually knew Tesla. So, and they were talking about these theories back
Really?
when Tesla was alive. Yes, Bert England. Yep,
Bert England.
from Great
You were
Britain.
saying that was
Very
even,
interesting.
you were saying that was even before the Foo Fighter Nazi crave, right?
Yeah, he actually spoke with Tesla before he died.
Right,
Bert
right.
England. That I did
So,
not.
or it could have been after. No, that would have been. Yeah, before.
Well, Tesla
So
died.
a thing that I
41.
find really fascinating with the Otis T car is the spinning, right? Because they say a bit to do with gyroscopic motion and the double cones, right? But the specific metal materials, the alloys that they use, and the fact that this is a what the heck is the electrical term called, where you have the step up transformer. It's a transformer, but you have a specific shape of it, and that the other side is the spinning double cone, so that you're
Right.
getting a huge electromagnetic energy out of that. And then you have the three separate different gyroscopic systems within it, so you have the field within the field within the field, and they
But imagine
massive
when we start
EM.
thinking electrics instead of just strictly magnets, because in that electromagnet you can literally have an electromagnetic field that puts a 90-degree force on something. That's what people don't get. Like, you can have an electric and you can spin a disc just by having that field going 90 degrees to it. You know what I mean? Electrics, they don't seem important, but it's just as important, and people are just focused on the magnetics, and the magnetics are really just a waste of energy.
Yes,
Like,
yes, they are. Yes, they are.
Yeah.
Yeah, no disagreement there. Well, it depends. It depends on what you're trying to achieve, I guess.
Yeah. Agree.
If
But
you're using
in
it to
general-
collapse fields, then
In
it's
general, it's more difficult to conserve the power of a magnetic field than it is an electric. In my opinion, I don't know. It's difficult because you can have supercoolers to drop the temperature and get super magnets that or you can have an electric field that just sits there and has potential, and energy is literally the potential.
Right, but you still need to be able to vector that energy into the electromagnetic mode that you're looking for the purpose at hand.
Yeah,
So at that point, like,
it's easier. Though.
It becomes a but-for situation, though, because if it's a magnetic field that you need for, let's say, field compression, right?
Yeah,
then you're going to have the magnetic field, which is inherently wasteful, but it's just inherently wasteful of a unlimited potential source, right? So then what's the point of waste?
Yeah,
you see what I mean?
It's a necessary waste to get the effect that you want. It is.
But when the well is unlimited, what are you wasting? At that point, it's not a matter of waste. It's a matter of just generating, heat. Let's just say, or diffuse dissipation of of the field itself. So what are you losing?
What do we have here? We have some
just saying
Chinese people based from Beijing
because they can recharge themselves.
Right, and that's exactly the point of what I was saying. If the well is always full, and you're thinking about efficiency and waste,
it depends on
what's the difference?
It depends.
Like having an unlimited amount of money and then bitching about the couple bucks you spent at the drive-through. Like, what's the difference?
Exactly. I agree. I'm not disagreeing with you, brother.
No, I'm saying, making a point.
Yeah, you're right.
Oh boy, you got lazy Joe today, boys. And Lulu.
This is interesting. It's patent here. 2014, people from Beijing, United States patent, electrical driven flying saucer based on magnetic suspension. I need to get the rest of this one.
Chinese International Search Report. Dude, the Chinese people are going to take it. That's what I'm saying.
It's Chinese.
Wait, what do they do? They take like a magnetic shock absorbers out of a Cadillac and decide to bounce them out of phase?
No. Hey,
perpetual jerk off UFO
patent by the inventors that based out of Beijing.
Honestly, United States patent doesn't matter when it comes to China. They're just gonna rip it. I know
it's Chinese people filing it in America. What do you not understand?
Intellectual property, bro.
You misunderstand. You do not understand the scope of this.
Look at the sentence. Chinese International Search Report. Other publications.
No, it's Chinese-based inventors filing an American patent based off of a Chinese.
It's going
patent.
to China.
It's based out of China. You racist fuck! Give your head a shake. It's Chinese people.
I have a question. Do they have to follow the Chinese?
I'm not racist. Why are you calling me racist?
Do they have to follow the rules of whatever China in production?
It's based
for
out
example,
of China.
What?
I know, but do they have rules in China about if no two companies can manufacture the same thing?
No, but then they refiled it in America.
They can compete for the price and just squash it because they can
Chinese
get lower
inventors with a Chinese patent that then filed it in America afterwards.
TR3B. I'm saying the
So
TR3B.
why don't they manufacture it there and then put the patent here, and then that way
that's what they obviously did,
worlds.
Lulu. That's the whole thing. That's what's obviously the case because the patent in China was it's based off of a 2011 original Chinese patent. Okay, see, 2011 when the Chinese filed it and built it in China, then they came and filed it in America 3 years later. So it's built in China, based out of China. Then they patented it in America.
How am I racist?
Because
You call me a
didn't
racist, bro.
grasp the
So who
fact.
filed that? Some dumb fuck.
Yeah. Here you go. Zhu Yang Hu and Xiao Gang Ruan, both out
Very
of
nice.
Wei. There you go. All right, sorry.
Why am I
I
racist?
take
bro?
it back. I take that back. I'm
I'm fucking
sorry,
with you.
Jarvis, but you just
Nah.
weren't grasping the fact it was from
It's
China
true.
by
It's true.
Chinese people that then after filed it in America. Like the relevance of that is huge.
I'm just joshing, man. I'm just
All right.
joshing.
TR3B concepts.
TR3B is cool.
Quartz bulb. I find this fascinating. Always the quartz crystals in these, and that the other main one.
Edgar Fouché is really
bunch.
the man you want to look at when it comes to the TR3B.
Oh
Edgar.
yeah. Yep. Jeremy Reese and Dan Solar Marshall, very good friends with them. Okay, these things showing up in so many of the modern, newer UFO disc-shaped things, and they say this is also quartz sphere bulbs at the top. Very, very interesting when it comes to the quartz technology.
Dead Fish would love that, right? Joe Fuchsias.
Yo, yeah, man. He's been all about it, and I think that once he gets things up and running himself, he's going to be doing some cool stuff with that. I have a few things that I want to try too, but I don't know. I feel like some of the things that I have an idea for at this point involving quartz is kind of risky to my hardware, so I might hold off on that for a little bit and maybe enjoy it.
Roger.
So here we go. Here's where these things are and these craft.
Oh, is it a pit?
Well, my dog, yeah.
Mm-hmm.
There's like
He's
a
a blue
whole
nose.
bunch.
Good boy.
How do people hate pit bulls?
I don't know, man. This dog is like
I love pit bulls.
They're so gentle.
this dog is the biggest mush.
If you ever have a pit bull that is ferocious, it's because you're a fucking bad parent.
Yeah, no, my dog loves me.
I agree.
I'm his world.
Pit bulls
Nice.
are generous.
He's a big
They're
boy.
only
He's like 80 pounds.
Make them ferocious.
Yeah. He's in like, Dad, you haven't spent any time with me today mode, you know?
Aw.
Mine's the same way. Gotta take him for a walk after.
Oh, yeah.
You got
Oh
to.
shit! We gotta do a close up here. We got a celebrity on. Oh.
Say hi, Matt. It's over there. Look. There you go.
Oh. There's a puppy.
You got his attention there.
Right there. Yo.
As long as he doesn't look the camera, you're good.
Who's that?
Right?
It's like, I'm not good with this now. It just freaks me out.
For real. Oh, balls.
Here's
Yeah, so
me on Lola.
We had Elijah on today earlier. And if anybody here missed that episode, I strongly recommend you go back and check that out.
I didn't see it.
Dude, he's up to some really, really good stuff. And I'm going to tell you right now, experimentally and like proof of concept wise and everything like that, he's, as far as I know, ahead of everybody.
Yeah.
I'm telling you right now, and the guy knows exactly what he's talking about. He had an interesting story about like a encounter that he had, and then he went into everything that he's doing and how he got inspired. Very, very worthy thing.
Was that on OMB?
Nice.
Yeah.
All
Yeah,
right.
it was on earlier today.
You talking about Nathan?
You watch it in full. Yes, on Nathan's channel, Old Man Bill.
Yeah, Elijah, he's intuitive too. Like Lulu's intuitive, because what she was working with the glass and the gold wire. Could you show that, Lulu, if you still have that? Like that was similar to what they were doing in the skull experiment. If you ever research the skull experiment, it's like I said, it's not skull experiment. It's like
SK,
SKO.
OHLE or something.
Yeah, it's not like skull, but there's a radio that you can communicate with the dead with, and um, Edison actually gave them blueprints, and they were taking pictures with
was dead though, so
undeveloped-
Edison channeled it to someone.
Yeah.
That's a key part. So he
and
gave
they were
it to someone.
they
in
were
the
taking
room.
pictures with undeveloped film and setting it into the crystal type of thing that Lulu has, like similar to what she's doing. They would set the undeveloped film in there and then develop it, and then the Edison blueprint was on there to show them how to make a radio to communicate with spirits. That's
Okay, can you see it?
Imagine that. Imagine a future where you could like literally talk to spirits. I mean, that's
You imagine a future where you can
Yes, it was
reincarnate anybody.
yes,
Right.
it's just like that. See, the gold around there really matters. Like they always said that it should be a gold, like real gold, and that looks like
Wire.
real. Yeah. You
Yeah.
see?
Yeah, and
Is real
people
gold
people
wire.
got to remember gold plating in that context is just as good as a solid piece of gold.
But the gold they stressed was important.
Depending. Pure gold.
Do you feel like you get any
If
vibes
you're
on
doing
that?
resonance or just the field.
Oh well, yeah. I mean, if you're looking for gold resonance, but as far as like electromagnetic properties are concerned,
Gold is superior. I mean, there's a reason it's noble. I mean, of course, platinum too, but what she's doing there, it's weird because it's like it's on a different frequency. Like you're changing channels. She's tuning into something that we're all using copper with, so we'll never even get there. Period.
Look,
When
I
you
have
start using gold like that,
I have something else. I put it next to this thing. Okay. This is like your little thing that to make a circle.
compass.
Is it a compass? Yeah, no, not a compass. Yeah, a compass.
Compass.
And then I put two little coiled. These are hair clips, honestly, but I thought that I could use this spring came from a pen. Took it out, and then I wired it into this and made it's like a resonator in a way, but it's a double
Nice.
resonator.
yeah, very cool. Very
It's under tension too. That's cool.
Yeah. So I put it next to it, and to if it's offsetting anything, this is gonna somehow like propel it.
Nice.
So that was the original concept. I think it works. I think
Well,
100%.
the stainless steel, if it's galvanized, that little spring there, I think stainless steel is really important, especially galvanized stainless steel, and making it like as a spring, because literally the energy stored in an inductor is related to a spring constant.
Yeah, but look, it also still has a center. Like it goes through. Like, okay, let me unclip it so you can understand what the like. Okay, you see, it's like two things here. I can take it off.
Okay.
All right. So this one, I fed this one into the original, which was one piece. This and this.
That's so cool. She's intuitive, the guys.
Very
And then-
nice.
I put this because now it creates like you have to, like a 0 and a 1. This would be like the 1 and this would be the 0. So
You're going binary.
do you see that?
That's cool.
Yeah.
Like people don't understand. Like some people, I think, can sense and be engineers naturally. You know what I mean? And it's just cool to me because I really think, from what I've seen, that she's onto something spiritual radio type things. And the skull experiment, she just reminds me so much of what she's doing there.
I can bring another one if you're really interested in this stuff. Like I have got many models that I Uh-huh.
I'm totally interested. I mean, if you could make a radio that communicates with the dead, you're a billionaire. You know what I mean? Like anybody would like to
Well, the
converse.
Skull Group already has, and I don't know if they're billionaires, but it's because most don't believe, and it's also censored.
Dude, just look up the skull experiment. They're talking with aliens too. It's not just spirits that they were talking with. They were talking with aliens, and they're saying that the ionosphere plays a part here. And they said that the wave they worked with was in our microwave region. So it's a short band. They worked off short band waves. And like I said, back in the day, they used to be able to detect it easier with baby monitors, and real walkie-talkies use short band, and they used to use the ionosphere to bounce off to get longer distances. You know what I mean? But that technology is old, and you know the radios that they were using in the skull experiment could do that.
Did you know that some research in Russia said that when you die, your soul is kind of getting warped in a different galaxy or something like that? It's not another dimension, but another galaxy. But I kind of agree with that. That there's no parallel universes. We're all in the same realm, and we just go live somewhere else when we die. So that's these are my beliefs, not based on religion, but based on mathematics. There's no such thing as different dimensions.
Yeah, and what I'm trying to say though is once you start using gold, it's a completely different thing because everybody either uses silver or copper when it comes to coils. You know, and it's a different, like, gold is literally the best.
Gold coil is the dream coil. It's like, is that what
Gold-
those halos were made out of on Angels? Was triple
Gold-
solid?
Gold is the best microwave reflector. Like the NASA scientists that went into space had to have a thin layer of gold on their visor in order to see stars to get the reflection. If you just looked out into the darkness when you're in space, you wouldn't see the stars without this gold reflector on your visor. They had to use gold to send
Webb's mirrors. They did that.
I'm just saying it makes a difference.
So here, you want to talk to the dead? Talk about this idea real quick. This is a great group to kind of throw it at, and it was something we briefly discussed on the show today too. Right. So if you have 2 Tesla coils, right, and you have them 2 separate channels, and you're able to pump slightly offset frequencies through them to create a beat frequency at the scalar interaction zone where the deconstructive interference takes place, leaving an offset bias remainder. Okay, the same as binaural beats work, except just in an electromagnetic field in resonance. Then what you do is you distance them so that interaction field, let's say, is like 6 feet apart. The coils, right? You could sit in the middle of the coils at that torsion zone, you know, where the scalar is created, and fall into a resonance with all the frequencies that are being used, both the native frequencies as well as the scalar offset bias. Then, if you introduce binaural beats into the equation to get your brain waves synchronized at the same in sync with the input of each coil, the native input of each coil, now you're putting your consciousness into the same wave pattern in hemispherical synchronization, right, as your body. So what happens when you have full, what happens when you have full mind and body coherence?
I want to experiment with
that. I want to know too. That's what I'm saying.
Okay,
so,
I don't want to be the first though, just in case you get decoherence.
You know, like, you have to make sure that the frequencies are compatible with both your consciousness and your biology. I think that's a critical,
right? Exactly.
Critical aspect.
I get Facebook ads, and they they claim to have found the God's frequency and things like that, and different frequencies. But I'm not sure if that's true. But it kind of reminds me of what you're saying right
Well,
now.
I mean, that's a part of what I'm saying. So it's not a simple, it's not a difficult concept, but it's not simple either. Those frequencies that you're kind of referring to are just a single frequency. Okay. Um, these are offset frequencies. So like, you could have one at 432, but then you have one at 435, and then you have an offset bias of 3. So when you have the deconstructive interference that takes place, it basically has the native frequency being induced into you because you're in that field. But there's a scalar interaction that's taking place at the event horizon, interaction zone, torsion zone, whatever you want to call it. That creates an offset bias of 3 hertz in that case, right? So what ends up happening is your body is getting 3 different frequencies, and it's going to equalize at the offset beat frequency in a pulse modulated fashion at 3 hertz. And the same occurs with your brain. Now that's a known and positively, known way to induce, different states of consciousness through audio waves. Now, if you utilize the audio waves the same and with the field, now you have your body in coherence with your mind, which is both in an altered state of resonance. Right. So that's the concept at hand. So it's more than just one frequency, multiple frequencies and their interaction.
Yeah, see. Is Mike sleeping right now?
Might be.
He's
I'm
sleeping.
I'm just
I just woke
listening.
him up.
I have the can you guys hear me?
Yep.
Okay, I have the models. If whenever you're ready to see them, I got them out. That looks good. What is he cooking?
What?
Right.
Making some noodles.
No, I'm
Yeah, he made me hungry, so I had to go eat.
Oh, right.
Food.
Yeah, I just cooked myself something. It's fun when there's not just me. I can scoop out and go cook something.
Yeah, there. Oh, he's back. The chef, Chef Jervis.
Chef Jarvis, that looks rather white, man. You should season your food.
I did with
MSG.
Yo. Oh, yeah, I'm unmute. I thought I was muted. It was Creole. I put Creole on everything.
You gotta kick that up a notch, brother. It's looking a little white.
That's for his dog.
Dude, I've been torching it. I've been doing all kinds of stuff to this stuff.
Good.
This is actually going to somebody else, though. I'll be right back.
He's feeding the family. Then we got our French chef in Montreal.
Yeah. I'm far from being a French chef, but don't worry about that. Although every week I make myself the same meals I like, my favorite meals. Can I go wrong?
That's easy when it's just you and you don't have a family to feed. Then you got to figure out what everybody else wants to eat at the same time. And if
that's the hard part. See, if everybody would eat everything, it's actually easier to feed more people than it is just one person.
Yeah,
you don't want to pain in the ass to just for yourself.
They say that our culture has a low fertility rate, and I'm not contributing to that, unfortunately. Sorry, guys.
Jeremiah's here.
It's all right, dude. I've made up for you.
You have 20 kids?
Here.
No, not that many, but I'm definitely at a net positive. Here we go.
Jeremiah is here.
You got
That
something
was-
to share?
Should end with a prayer for world peace, because my God, are we on the brink?
Yeah, but the Israelis and Iranians going at it again.
Yeah, that didn't need to happen.
No, that did
No.
not need to happen, and what a catastrophe that is.
Did you know China? They discovered like a gold mine, like the biggest in all history. These people are gonna get they're not over yet. You know, they're gonna have thorium also, so that generates energy. Thorium,
Oh, thorium reactor. Yeah,
Yeah.
yeah. That's what we should be building: thorium reactors.
yeah. So
Yeah,
they,
I think Iran is gonna enter into f around and find out mode though. Unfortunately, it's I hate to say that, and it's definitely not what I wanted to see. And yes, is it a false flag? Nah, absolutely, they all are. I agree with that in the comments. But that said, that doesn't mean that these things aren't happening. No matter how false flag they are, these things are happening, right? And at the end of the day, there's going to be more result that occurs from it. So I don't know. I think Iran fried themselves, but by virtue of
Iran
Israel,
didn't
that's not
do
cool. They
anything.
kind
It
of
was
screwed us over.
Israel that attacked them. Like, they were just sitting there trying to negotiate.
Yeah, I know. Israel decided they didn't want didn't want to negotiate no more. The answer was now.
Yeah,
I
the
think
Israelis.
Trump didn't want Israel to strike Iran or something like that.
Yeah,
Well,
and
Israel
dragging us
Israel
into
wants to
stuff.
fight. Israel
Yeah.
wants to fight. So
Yeah, well, I mean, there's a certain part of it that I understand that I respect, and it's not a matter of war. It's that everybody in that region's been at war with them for all eternity.
yeah,
So
sorry, they'll never learn.
yeah,
They'll never learn.
well, it's never learn or
History
never,
repeats itself.
never learn or never give up. That's the rough thing about it,
History
all I-
repeats itself,
It's all going to end in a big mushroom cloud.
Probably.
Or
That,
peace
that would
through
resolve that problem.
technology. Peace through technology. Why we need to advance very quickly now.
Yeah.
We're
Well, there's
getting there.
always going to be somebody that wants more cake than they have, and that's what leads to these things. So, yeah, will this alleviate some of it? Probably, but at the
You
end of
know
the day,
what I
there's
really
always
want to
somebody that
do?
wants more.
I want to make a real Cozy Rev mirror, Joe.
Yeah, man, me too.
Yeah.
I want that. I want
like
that.
where it literally spins on a platform and stuff. But instead of the
I'm in.
thawing eyes, I want to play a record. Let's play like old magnetic tape record, because instead of the thawing eyes letting the time go, let's just like play a magnetic tape of a record in the past and try to tune into it and see if we can go there. But you have to have the Cozy Rev like spinning around and in its spiral form with the mirror structure and everything, while these cassette players are emanating the time of the recording. You get me?
Right. Yeah, you need something to create that quantum connection.
Yeah, something that releases the time instead of the ice. Something that's literally recorded. And yeah, maybe you can go back to 1920s, but that's still cool. I can go back to the 1920s.
Sorry
You know what I mean?
interject, but we are reaching that 2-hour mark.
Yeah.
All right.
Should we just end her and do private a little bit?
Yeah,
I'll
we
tell
can
you
do
what.
that.
I'm down for a private.
Before you end it, you want to touch one real quick. It's
Yeah, 30
interesting. It has to
seconds.
do with it has to do with
30
Ashton. I was talking to
seconds.
old man about this. So check this out. Remember Bearden in '85 when he was talking about the scalar intersection. You create a vacuum. And then you chuck the energy back, goes return to sender, rubber band snaps, right? Goes back where it came, or you could redirect it, right?